I'm Anil Kumar. Let me thank all the viewers and subscribers for posting questions, writing comments, and participating actively on my YouTube channel. That has really made it very interactive and useful. Here are a few questions from one of my subscribers. These are all multiple choice questions in which we can also review polynomials division, especially remainder and factor theorem. And here we are working under the domain of x belonging to complex numbers. Right? Just to remember that. Okay, there are 6 questions which we are going to answer. Here are first 2. I'd like you to pause the video, copy these questions, answer, and then we'll move on. Question number 1. X to the power of 33 minus 7x plus 1 is divided by x plus 1. Then the remainder is what? So in this case, what we can do is that we can just find the value of this polynomial for minus 1. So what makes this 0? So the idea is you have to equate this to x plus 1 to 0. So that gives you the value of x as minus 1. Substitute minus 1 in the polynomial and whatever you get will be the remainder. That's the remainder theorem. Is that okay? So we are applying the remainder theorem here. Substitute minus 1. So we get minus 1 to the power of 33 minus 7 times minus 1 plus 1. And that gives you odd power means negative, minus minus means positive, plus 1. Minus 1 plus 1 is 0. So you are left with plus 7. So option B is the right option. Question number 2. The function f of x equals to minus x cubed plus x minus 4 has a real 0 on which interval? So we are given 4 different intervals. We need to find where is the real 0, right? So what we can do here is that the intervals are from 0 to 1, minus 2 to minus 1, minus 1 to 0, 1 to 2. So in such cases, let us analyze the situation. What we are given here is that we are trying to figure out where is the real 0. So intervals are from minus 2 to plus 2, right? So for each point, we'll try to test the value of the polynomial. So let's first test at minus 2. What do we get? Do we get a positive value or a negative value? So what I will do here is, we'll just write the value minus 2 in the given polynomial and evaluate. So minus of minus 2 cube plus minus 2 minus 4. We get minus 8, right? Minus 2 cube is minus of minus 8 will makes it plus 8, right? Minus 2 cube is negative. Negative and negative will become positive. And then we have plus and minus, which gives us minus 2, and this is minus 4. And that is positive 2. So here at minus 2, we have a positive answer, right? So we have a positive answer. Let us now calculate the value at minus 1. Substitute minus 1 here, minus 1 whole cube plus minus 1 minus 4. That gives you minus 1 cube is negative. Negative or negative is positive. So you get plus 1. Plus and minus is minus 1. And we already have minus 4. And that gives you minus 4. So here we get a negative value. Do you see that? So here we get a negative value. Now it clearly indicates if you are moving from positive side to negative side, there has to be a 0 somewhere in between. And therefore the solution is B. It is within the interval minus 2 to minus 1. So I hope that makes sense, right? So check the value of the polynomial at each extreme value of the interval. If it changes sign, right? So it changes sign. In this interval, minus 2 to minus 1. So that means there is a 0. or a real 0, right? So that is how you could calculate it. So I hope that makes sense, right? Question number 3. Synthetic division of some polynomial f of x by x minus I is given below. So that is the synthetic division. Find the quotient. We are given 4 choices. Now let's look into the synthetic division part. So from the situation, it seems that it's a cubic equation which is being divided by x minus I. So dividing by I, you get that as your quotient, and 2 plus I is your remainder. So this part is remainder and that part is quotient for you. And clearly the quotient has to be a quadratic function, right? Now, since we are given A, B, C, D, E here, we have to figure out what these alphabets correspond to get our quotient. So we'll start from this side. The remainder of 2 plus I is possible if I add what to 2? I have to add I to 2 to get 2 plus I, correct? Now, to get an I here, we have to multiply by what? To get an I here, we have to multiply by 1. So I times 1 is going to give us I. So we get the value of E. We need to find D, which is just sum of I and I. So it is 2I, right? So now it's very clear. 1 over here, 2I and 1. And therefore, we can write our quotient as x squared plus 2ix plus 1. Does it make sense? So which corresponds to option B. Is that clear? So that is how we can do kind of reverse calculation to find what the quotient is. I'd like you to go through it carefully and see how easily we could solve such a question. Now let's move forward and take up question number 4. It says if 3 is a 0 of this function, then the other zeros are what? So if 3 is a 0, we can divide the whole thing by x minus 3 and find the others, right? So in this case, let me do long division instead of synthetic division, and then we'll factor the quotient. So what we have here is we are dividing x cubed minus x squared minus 4x minus 6 by, if 3 is a 0, we have to divide by x minus 3, right? So dividing that, let's see what the quotient is. First, you have to multiply by x squared. So we get x cubed minus 3x squared. That gives you 2x squared minus 4x. 2x we have to multiply by. So we get 2x squared minus 6x. And that gives you 2x minus 6. Now you have to multiply by 2. So we get plus 2 here. So we get 2x minus 6 as expected. Remainder is 0. So to find the other zeros, we have to factor the quotient, which is x squared plus 2x plus 2. So we have to factor x squared plus 2x plus 2. Let's say y equals 2, right? So we can use the quadratic formula here. X is equals to minus b, which is minus 2, plus minus b squared, which is 4, minus 4ac, which is minus 8, over 2 times a, so that is 2, right? So that gives you minus 2 plus minus square root of minus 4 over 2, and this is minus 2 plus minus negative square root is I, and for 4 we get 2, right? Divided by 2. Now 2 is a common factor, so I could write this as minus 1 plus minus I over 2. So that is our answer. minus 1 plus minus I, 2 cancels, I'm sorry. So 2 is a common factor. So the last one, D, is the right answer. Correct? So let me redo this. I did a mistake here. So we could factor out 2 here, right? So we could get minus 1 plus minus I over 2. So this 2 and 2 cancels and we get minus 1 plus minus I. Correct? So option D is the right option. Now let's look into question number 5 and 6. Question number 5. When x plus 2 is divided into f of x, the remainder is 3. Determine the remainder when x plus 2 is divided into f of x whole square minus 2f of x plus 1. 4 choices are given to you. Now that's a thinking question. You can always pause the video, answer this question. When we divide a function by a linear factor like x plus 2 and we get a remainder, it really means that f of minus 2 should be equal to 3, right? That is from remainder theorem, right? Now we have to divide this modified function. What should be the remainder? That's the question. So basically substitute minus 2 and then figure it out. Right? So what we get here is we get f of minus 2 whole square minus 2 times f of minus 2 plus 1. Now f of minus 2 is 3, so we get 3 square minus 2 times 3 plus 1. Now 3 square is 9, right? Minus 2 times 3 means minus 6 plus 1, and that gives you 4. So option D is the right option. Correct? Last question here is, if f of x equals to x plus 7 times quotient plus remainder x plus 3, what is the first multiple of x plus 7 greater than f of x? Now again we are given 4 choices. You need to solve this question and then look into my solution. Now clearly f of x is not divisible by x plus 7 since we have a remainder. Now the remainder is, as you can see, x plus 3. Divisor is x plus 7. Now if I add 4 to this, then the remainder will be x plus 7. We can divide evenly. Do you see that? Therefore, f of x plus 4 is the next multiple of x plus 3. So option is D for us. Correct? So that is how we could solve this question. I hope you find this set of videos useful, just as my subscriber finds it. And I hope these solutions work for you. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.